Hey, what's up guys? This video is for section 1-1 variables and expression part 2. Now in part 1, my other video that you guys can watch, I talked about what is an algebraic expression with variables and numbers and exponents, and then we talked also about how to write a sentence from an algebraic expression. So we say we translated an algebraic expression into a verbal sentence. Well, today for this video we are going to do the opposite. I'm going to give you guys a sentence and we are going to look for the algebraic expression. We need to know how to translate from a sentence to an algebraic expression and also the other way. So let's go ahead and look at some examples. Alright, so now we are going to do the opposite for these examples. It says here to write an algebraic expression. So notice that I have 6 different sentences and we want to make those in algebraic expression with variables, with numbers, exponents, whatever the sentence means. We have to make sense of the problem and then we have to write down that expression. So let's go ahead and look at the first one here. And we have 4 times a number plus x. So pretty straightforward. You guys can see the word times, and those are the ones that you guys need to find, the keywords that represents a math operation, and variables with numbers or maybe with exponents as well. So we know that times, I'm just going to underline this, is you are going to multiply a number. Well, you can use any letter in the alphabet to represent a variable. I'm just going to use x for this time, so that's going to be my variable. We do have a plus right here, so I'm going to put a plus on the top, and I know that I am going to add plus that number 10. So when you guys take the times, remember that we don't use the symbol x anymore for multiplication. You are going to multiply, which is the word times. So I'm going to put a dot on the top here just to remember that I am going to multiply. So I'm going to bring down the number 4. I'm going to multiply times the variable, a number, so I'm going to have x here, and I do have a plus and a 10. Now here, we don't need that times in the middle, because remember when you have a variable with a number, you don't need to put, and they're multiplying, you don't need to put the times in the middle. So I'm just going to write down the 4x, and I bring down the plus 10, and that's the algebraic expression that represents this sentence, 4 times a number plus 10. Now this one, it says a number subtracted from 5. So let's go ahead and understand the problem first of all. So we do have a number, and I'm going to use a different variable this time. I'm just going to say y for a number. You can use any letter in the alphabet, but that's the one I choose. And the next keyword is subtracted from. So I'm going to underline all of this here, subtracted from. And I know subtracted, that's going to be a minus, so I am going to subtract subtracted from 5. Now, there's very important that you guys remember the word from. So I'm just going to circle that word right here, from. Because the word from, the word then, and the word into, if you guys see those in a sentence, that means you have to switch the order of the operation. So you are going to subtract. I'm going to put the minus right here. But when it says from, well, this number 5, a number subtracted from 5, it actually has to go first. Even though it's at the end, most people put that 5 at the end of after the minus, and that's where the from, the word comes in. You have to switch the order. So this 5 has to go first. So I'm going to put the 5 here, and you are going to put a number, which is the y that I chose, the variable, after the minus. So I'm going to put the y after the minus, the sign of the minus. You subtract it. So it's very important that you guys understand. And let me just put some arrows here so you remember that you have to subtract. When you hear the word from, subtracted from, you switch. Let me just put an arrow like this. You have to switch the order. So notice one more time, the 5 is going to go first, and a number, whatever variable you guys choose, is going to go after the minus. And I'm going to emphasize this. I'm going to repeat myself. The word from is what tells you to switch the order. This one is just like the previous one that we just did, where you guys had the word from. Well, this one says x more than 9. So we know more is going to be plus, so I'm just going to add. But the word then right here, when you guys hear the word or see, you read the word then, from, or into, that means you have to switch the order. So this x, they already gave us a variable. I don't have to choose a different variable because it says x more than 9. Well, you guys, we have to switch the order of those two terms. So I do have a plus right here, but the 9 is going to go first, 9 plus, and the x is going to go second. So we do have x, even though it's at the beginning of the sentence, you have to switch. So you're going to put it at the end, and the 9, you put it first because you switch the order. This word then tells you to switch the order of that algebraic expression. Now this one, it says 2/3 the square of m. So first, let's understand the problem. We do have 2/3. We know that's going to be a fraction. 2/3 is 2 over 3. So that's the first thing we need to know. 2/3 is a fraction. And then we have the squared of m. Now, the squared, that's going to be an exponent. And square means 2. So you are going to have an exponent of 2. The word of means you are going to multiply. So I'm going to put the dot on the top. I'm not going to put the x symbol because remember that's actually a variable now. So we don't use x for multiplication, but we do the dots on the top. We are going to multiply. And the variable, they do give us a letter that represents the variable m. So this one, you don't see the word then, you don't see the word from, you don't see the word into, so you're not going to switch the order. You're just going to keep it as it is. And I'm going to start with the fraction. I have 2/3 times the squared of m. And I am multiplying one more time because it says of. So here, I'm going to put the variable m with the squared on the top. So there's your exponent of 2. We don't need that times in the middle. So we put 2 over 3 m squared. So that is your algebraic expression. The fraction, you multiply the variable m with the exponent of 2, which is the squared of m. Do not put the 2 at the beginning of the m because that's something else. I see that a lot. So it has to be an exponent because squared means exponent of 2. Now this one is where you guys have a different way to write down times 2. But let's read the sentence first. It says 5 increased by twice a number. So first, let's understand the problem. I don't see the word from, I don't see the word then, I don't see the word into, so I'm not going to switch the order. But I do have the word increase. 5 increase, so that's going to be plus. That's what it means. The word increase, it means you're adding. You're making it bigger. So increase, you're adding something. By twice a number. So first of all, a number is going to be my variable. So I'm just going to use the letter m for this one. Okay, so there's my variable m, a number. Now when you guys say twice something, well, that means you have to multiply by 2, not an exponent of 2. That's be very careful because it doesn't say the square like the previous example, but it says twice. So twice means you are going to multiply by 2. So I'm just going to put 2 here, multiply by 2. That's the twice word, multiply by 2. So let's put everything together. I do have 5 increase plus twice a number, so 2 times the variable m. You are multiplying by 2. I don't need that times in the middle, so I can put 5 plus 2m for my algebraic expression. So I'm just going to emphasize this a little bit more. You guys do have the 5 increase, so we have the 5 plus twice a number. That means you multiply 2 times that variable that you choose from the alphabet. It can be any letter, but you guys have 2m. And here's one more. It says 20 divided by t to the fourth power. So just make sense of the problem, and you are going to write that as an algebraic expression. So I'm just going to underline a few keywords that we need to know. So 20 divided, you guys know that's division. You are going to divide. So you are dividing by what? Well, we do have the variable t. That's what they tell us to use. 20 divided by t. But then it says t to the fourth power. So power means you guys have an exponent. And that exponent is going to be for the t variable. So let's go ahead and put this together. Now, I know that in the past you have seen the symbol for division, which is this one right here on the screen, the one you guys see. But in algebra, we stopped using that symbol and we write it as a fraction. So I'm just going to kind of erase all that right there. Let me just get rid of it. And once you guys understand that division is also fraction, when you guys have fractions, you are dividing. Well, let's start with the division line. So here's the division. The first thing you are going to put in the numerator, which is the top of the fraction, is the first thing that you see in the sentence. So we have 20 divided by. So I'm just going to put the number 20 on the top, and on the bottom I'm going to take the variable that is given to us, and it's a t. So 20 divided by t, and we do have exponent of 4, so it is going to be to the fourth power. So we have 20 divided by, there's the division line, by t is on the bottom, to the fourth power. So that is your algebraic expression. And the last one we're going to do is actually putting everything together. You guys have an application problem, which is just a word problem. But you have to first understand the problem. Remember, that's how you start with a math question. You understand the problem. Then you guys plan a solution. After you have an idea what to do, you have an actual plan. You are going to execute that plan. You are going to do the work. You are going to solve the problem. And the last step, make sure you guys check your answer and ask yourself, does it make sense? The answer I got doesn't make sense according to the problem. So let's go ahead and read what it says here. And it says, a used bookstore sells paper fiction books in excellent condition for $3.50 and in fair condition for $0.75. We want to write, and it says here, I'm going to circle that word, write an expression for the cost of buying X excellent condition paperbacks and F fair conditions paperbacks. So one more time, let's go ahead and understand the problem. It says here that you are going to write an expression. So we are looking for that expression that represents this question. And it says we want to write the expression for the cost. So we want to know what is the cost, how much we have to pay when we buy those books. And we have two types of books, and they actually give us the variables that represents those two types of books. So we do have the variable X. X is excellent condition, and we also have the variable F, which means fair condition of those paperbacks. So let's go ahead and make sense of the problem. When we go back to the beginning, it says here that books in excellent condition are for $3.50 and in fair condition are 75 cents. That's 0.75, 75 cents when they are in fair condition. So the way you guys can write an expression to know how much you are going to pay, well, let's make sense. First of all, you have to know how many books you're going to buy. And even more, you have to know how many books are in excellent condition, and you have to know how many books are in fair condition. So this is, in algebra, how we set up our variables representing something from that, from this example. So first of all, I'm going to write the variable X. X is going to equal excellent condition. So we have a book in excellent condition. And F is going to represent fair condition. So first of all, we have our variables, and that's what they tell us. They say to use X and to use F. Sometimes they don't say, so we just have to choose any variable from the alphabet, but they do have X and F. In order to find out how many excellent conditions, how much you have to pay for those books, well, you have to count how many books you're going to buy. So X represents that number. Maybe you buy 2, maybe you buy 5, maybe you buy 3 books. But no matter how many books you have or you're going to buy, you need to multiply by the price of each book. So the price for excellent is $3.50. So this variable, you're going to have to multiply by the price. So I'm going to take $3.50 times X. And X is going to be the number of books I buy in excellent condition. So that's why we say X is a variable, because it varies. It can vary. You can, like I mentioned, you can buy 3 books or 5 books or 10 books. So the number varies depending on how many books you're going to buy, and it can change at any time. But then you also need to know how many books in fair condition you are going to buy as well. And once you know how many, well, you're going to add everything up, and it's going to give you guys the total cost. So I'm going to put plus right here, and I'm going to take the price of fair condition, which is 75 cents right here. So I'm going to put 0.75, and I'm going to multiply by the variable F, because F is in fair condition. So let's make sense of the actual expression here. You have the price of excellent condition times X, which is how many books you're going to buy. So maybe 1 excellent book, or maybe 2 in excellent condition. And then you guys have the price of fair condition, and F represents the number of books you buy in fair condition. So you can buy 1 in fair condition, 20 in fair condition. They're pretty cheap, 75 cents. So you might want to buy 20 and so forth. All of these guys right here is the total cost, is how much you are going to pay when you go to the register, when you guys are ready to check out in that store, in the bookstore. So I'm going to put C for cost equals. So this means that the cost, how much money you need to pay, depends on this equation. Now you guys don't need that times in the middle. So we can rewrite it as the cost equals 3.50x plus 0.75f. That is right here an algebraic expression that represents the word problem for these bookstores selling those type of books. They don't say to find out how much money or what is the cost after so many books. So we're not going to actually solve this equation. And I'm saying equation because we do have an equal sign here. We're not going to do that. They just want us to write an expression. And that is the expression that represents this word problem. Alright guys, so this concludes my video for this section 1.1, which is variables and expressions. If you guys like my videos, make sure you guys hit that like button. Don't forget to subscribe so you guys can get my updates on my videos. And make sure you guys practice, and I'll see you guys later.